Today I'm going to be presenting something a little bit different to usual, which is my PhD survival guide. So, because I'm now in my fourth year and this is term three, this is possibly my last lab presentation. So, I thought it'd be interesting to talk about some of the things I've learned along the way, some of the advice that I wish I had in my first year, and perhaps provoke some interesting discussions about how to actually do research and the practicalities of doing research day to day, rather than talking about any one piece of research in particular. Okay, so let me just get that sorted. Okay, so here's an overview of what I'm going to talk about. So firstly, I'm going to talk about writing, speaking, project management, then experimental design, the mental side of things, collaborations, playing the game, working at the right level of abstraction, and then finally tying it all together with how to make this experience as fun as possible. And at the end in the annex, I've also got some resources that I've found useful and that I'd like to share with everybody, and hopefully one or two you'll find useful as well. So let's dive straight into it. So each section is going to be separated into two categories. So I'm going to start with the theory side of things and introduce some broad idea or some model for thinking about how to do research. And then after that, I'm going to give some practical examples from my own experience doing a PhD here at Warwick. Okay, so before we get started proper, I want to first make some caveats. So first thing is that this talk is a collection of anecdotes. I know we're used to in these seminars talking about science, but this is not science. This is mostly opinion and anecdotal advice, which I hope will still be useful for people, but it should not be treated as science. And the advice that I'm giving definitely shouldn't be taken at face value, and we should all try and figure these things out, what works for us as individuals. Secondly, and related to that, is that there's a huge variance in people's experience doing a PhD. So I know that we need to make this work for us as an individual. So things that work for me are not necessarily going to work for others. Thirdly, I'm not very experienced. So I've only had 4 years of research experience, but I wanted to give this talk now because I think the freshness of the experience might be useful, because the so-called curse of knowledge, where as we get more and more experience into a field, it can be difficult to remember what it was like in the earlier days. And so given that I'm just now coming to the end of the PhD, I thought it would be a good time to reflect on some of the things I wish I'd known in the first couple of years in particular. And then finally, as I mentioned, this talk is aimed at myself from 4 years ago, and I hope that some of that will be useful to you as well. Okay, so let's get into the content then. So firstly, I want to talk about writing. So when I first came into the PhD, I think this was the model of science that I had in my head. And I suppose this model has probably come from school. And it's this idea that first we have some ideas, some hypothesis we want to test, then we'll run experiments. From those experiments, we'll update our hypothesis, have more ideas, and we'll be in this loop for some time. And this is the science, as I call it. So ideas, experiments, right? And we're in this loop for a very long time. And then once we have had this so-called eureka moment, that's when we start doing the communication, where we write the paper and we give the talk. And this is generally a smaller portion of the time. So we spend most of our time doing the science, and then a little bit of our time at the end doing the communication. But I don't think this is a very good model for thinking about how to do science. And the reason for this is, I tried doing this before. And what happened is, as you start writing and as you start giving talks, you'll have far more ideas than running experiments. So if you're relying on your experimental results to have ideas, you generally generate fewer ideas per hour. A lot of the best ideas come from when you're forced to write it down and explain your reasoning, and when you're explaining to other people in the form of a presentation, or a meeting with your supervisor, or a meeting with other collaborators. This is where most ideas come from. I have found. So that's why I don't think this is a very good model for thinking about how to do uh, research. And I much prefer this model where we don't have the distinction between the science part and the communication part. It is all the science part. When you're writing and when you're speaking, that is also doing science. It's not just restricted to your experiments. And I find when I made this shift, I generated far more ideas, and it also puts an emphasis on the importance of writing and the importance of uh, giving talks as something not separate from the science, but as a very important part of it. So in practice, I'm going to give some examples of how I actually approach writing. So in the first stage, I will always write a stream of consciousness. So the idea of this stage is to minimize any barriers to writing, because sitting down to write is quite a can be quite a challenging thing, as I'm sure we've all experienced. So what I like to do in this first stage is remove any spelling and grammar checker, remove any formatting or any fancy figures or tables or anything like that, and it's all about writing from what's in your head onto the page with no barriers whatsoever. So I like to use a separate tool for this. I use Bear. Again, I'm going to give some examples of tools. I'm not suggesting that these are the best ones. They're just anecdotally what I use. Um, and so writing, when you can remove the idea that your writing has to be good, and all you have to do instead is write and focus on quantity, it's quite easy to write a lot of text quickly, and it stops you from interrupting yourself when you say you write a sentence and then you'll go back to fix a typo, and then you'll reword it, and you're doing a lot of steps, which makes it harder for you to get into a flow state. So I like to just completely disregard everything else and go quantity and just write and write and write and write. Okay, so that's the first step. So the second step is restructure and refine. So I'll then take this lots of text and try and organize it in subsections. And when I say refine, what I really mostly mean is delete. Because if you've done the first stage correctly, you're going to have a lot of content, and a lot of it is not going to be very useful. So remove what you don't need and restructure the rest, and so you've got the workings of beginnings of a piece of text. Then the next step, I'll do the spelling and grammar check, or do it all in one go rather than editing it line by line. And as you can see in this example, there are many spelling and grammar mistakes from my first draft, because I'm not even thinking about how to spell words correctly. I'm just trying to get my thoughts onto the page as quickly as possible and not correcting typos. I recommend in this stage getting a grammar checker in addition to a spell checker. Personally, I use Grammarly. It's quite useful for these grammar checkers are getting really good nowadays and can pick up a lot of the common grammatical errors. So I find that helpful. Next step is adding figures and tables into whatever format you're going to use. I mostly use Overleaf if using LaTeX, but again, you can use whatever works for you. And then finally, it's only in step 5 where even thinking about the quality of the sentence structure of and all those finer details, and this is the editing stage. Now, this stage can last a lot longer than all the others, and it's far easier, I find, to edit something than it is to try and edit as I'm going along. So what I like to do is print out the final formatted paper that I've got from the last stage, or report, or whatever piece of text you're working on, and then I'll take a red pen and mark it like a teacher. I try to treat this stage as if I was a reviewer, particularly if it's a paper that I'm writing, and I'll highlight things that I don't understand, which may sound a little strange. You can say, well, how do you not understand it if you wrote it, right? Well, it does happen plenty of times, and something that I'd recommend is having each of these stages on doing each of these stages on separate days. So that gives you a little bit more perspective and allows you to treat the text as something that has been written by somebody else because you've forgotten all the details from a few days ago. So that might look something like this. If you say you've got 4 sections, I'll stagger each stage on different days. So I'm not doing the first draft and the editing on the same day, because when you try to do that, you can get too in your head and focus on finer details. But if you can sleep in between each stage, you can treat it like an outsider reading the text for the first time, particularly for editing. So it's nice if you can draft something and then come back even a week later and then edit it, and you'll see you can try and treat it more like a piece of text written by somebody else, and that is what a reviewer will see when they're deciding whether to accept your paper. So that's a good way to think about editing. And in the editing stage, I showed an example of how I do this with a red pen. But this is also the stage where you bring your supervisors in to look at the text directly. And something about when to bring your supervisors in, I find that it's good to make your text as good as you possibly can before you send it off to your supervisors, because if your text is poorly structured and full of grammatical errors, then the feedback that you get from your supervisors will be this restructuring things and spelling errors, and these are things that you could have fixed yourself. So it's best to make your text as good as you can make it, and then you can start to do the collaborative editing phase. Okay, so that's writing. I'm now going to talk briefly about speaking. So I think I came into the PhD with some false idea, which is something that I've been used to, particularly as someone that's come into it straight from school and then undergrad and masters and then straight to PhD in academia the whole way through. Is the first idea to get out of your head is that you're not presenting to be graded. If you're like me, like I say, and have been in the academic system all the way through, you'll be very used to giving presentations where you're graded, and that's probably the only time you've given a presentation. But these research presentations, you're not giving to get a grade. So, and it's not a very useful way of thinking about your presentations as well. So it's important to get that idea out of your head straight away and understand why you're presenting. So I think in my view, there are 3 reasons that you're giving a presentation. Firstly is to teach your audience something. Secondly is to deepen your own understanding. And thirdly is to generate new ideas, both for you and for your audience. So I think perhaps people think firstly about teaching your audience something, because this is the most similar to the presentations you may have done in school or earlier in academic life. But the other 2 are also really important parts of giving talks. In particular, deepening your own understanding. This is the kind of related to the idea I talked about right at the beginning with the science loop, and how writing and speaking can be the best ways to generate new ideas and to think about problems more deeply, because when you explain something to somebody else, you're forced to justify everything and anticipate questions. And when you anticipate questions and you realize that you don't know the answer to them, that forces you to deepen your own understanding. So these are the reasons to give talks. And given this, preparation could take a very long time. And I hear like a lot of objections to spending the time to prepare a presentation. For example, it's going to distract me from my research, or I don't get anything in return. I want to focus on writing my thesis. And I think these are both, I don't like both of these arguments. So the first one, because as I've said, I don't consider a distinction between research and giving talks. I think they are one and the same thing. And secondly, to focus on writing your thesis, I want to show an example. There is no need for you to treat your presentations as something that is different from your thesis if you don't want to. You can you can do some intelligent thinking about what you want to talk about. So in this example, here's a slide that you might remember from last year that was in one of my talks. And here is that same, well, awfully similar image that has found its way into my thesis. So you can use your presentations to help you work on your thesis. And if there's a section that you want to include, but you haven't done it yet, that might be a good thing to talk about in a presentation, and then you can reuse the same material. And on the objection of I want to spend time on my experiments, I think that relates back to this this idea of what I think is the science loop, where we have giving talks as a way of generating more ideas. So some things that I find useful. Firstly is start making notes well in advance, many weeks if possible, because what this does is once you have an idea in your head and you know what you're going to talk about, your subconscious will work away in the background without any effort on your part. And at least I find when I know what I'm going to talk about, ideas will just come, like, pop into my head every now and then. I'll read something and I'll think, oh, that would be useful to talk about. I'll make a quick note of that. And then by the time it comes to actually making the slides, I've already got a few ideas that kind of felt like they came for free, because I didn't have to work really hard to get them. I just chose my topic, and then the ideas came just day to day, rather than, like, having to really focus my attention on, oh, what can I talk about? What can I talk about? What content do I need? So that's my first tip. Secondly is that, remember, you know a lot more about your niche than your audience do. And this is related to the curse of knowledge that I talked about briefly, which is how it's difficult once you get deeper into your understanding on a particular field to put yourself in the position of someone a lot less experienced than you in that particular niche. So sometimes the things that you're talking about may seem obvious to you, but are in fact not obvious to others. And the good way to gauge whether you're delivering at the right level, giving the right level of background and etc., is to use the questions you get from the audience. So good questions that are engaging are generally a sign that the audience is understanding and is interested in what you're talking about. And I find there's often a disconnect between what my audience or what questions get asked by the audience and what I think is important. And this is really interesting, because you get to learn how your research looks from an outsider perspective. And it can often be things that are trivial to you seem like the most important things, and the most important things to you seem trivial to others. So it's good to have that constant course correction of the feedback from giving a talk, to let you know what bits are actually more important and what bits are the things that only you really care about because you've been working on it for this particular problem for a long time, and actually a lot of other people are not interested in these minor details. And it can be easy to fall into that trap when you're working on a problem for a very long time. And finally is to rehearse. I definitely rehearse my talks in advance and cut out all the most boring bits. This is also the best way to remember what you want to talk about. If you're giving a talk for like a lab seminar, which is 50 minutes, it can be hard to remember 50 minutes worth of content. So I find the best way to do that is just to run through it the day before. And that'll also give you an idea if your timing is right, if there's any particularly boring bits that you can cut out. So in a suitably meta way, here are my notes for when I rehearsed this talk yesterday. So you perhaps can't read my handwriting, but I've just got slide numbers and things that I want to change, or in particular down there, The talk was too long, and I deleted some slides. So let's hope I got the timing right this time after deleting this. Okay, the next section is called Fail Fast, Fail Often, and this is to do with experimental design. So, unfortunately, and this is a cold, hard, bitter truth, that most of your ideas are rubbish. Okay, and that's sad. Well, it seems like a negative thing first when you first hear that, but the good thing is, on the bright side, that you only need a few good ideas. So it doesn't matter that most of them are rubbish. It only takes one or two good ideas to do some interesting research. So, given that we know we have a lot of, we're going to get through, we're going to have a lot of rubbish ideas, and we need to find a few good ones. We have this needle in a haystack type problem. So, to get through your ideas as quickly as possible, I recommend trying to minimize the feedback loop between hypothesis test and result. So this is why fruit flies are studied in genetics, because they have a very short life cycle of only a few weeks. And this is why cicadas are incredibly difficult animals to study, because they have a life cycle of 13 or 17 years where they're buried underground and they can't be studied. So you can see how with a fruit fly, we can generate some hypotheses and find out the results within a matter of weeks. And with a cicada, if our experiments don't work, we've got to wait 17 years before they resurface. So I recommend, where possible, and of course it depends entirely on what your subfield is to move your research as much as possible in the direction of the fruit fly and away from the cicada. So here's an anecdotal way that I did this during my PhD. So I had an idea to use multiple camera views for trajectory forecasting instead of using one camera view. So I had a data set that had 15 cameras and as many hours of footage. So to test whether it's a good idea, first, rather than use all 15 cameras, I only used 3 cameras and just a few dozen data samples to see, is it actually possible to extend the single camera into multiple cameras. And it was only at the stage where I could get some preliminary results with 3 cameras that I would move on to more cameras. Now, one observation might be that, well, 3 cameras is not very interesting and wouldn't have made it as a publication, which is probably true. But what's important here is that I'm testing one hypothesis at a time. So if it worked for 3 cameras and then I tried to scale it to 15 cameras and it failed, then we have another interesting problem, which is the scaling problem. And why do 3 cameras work and 15 cameras not? Do 10 cameras work? Do 5 cameras work, etc.? So when you're presented with the realization that 15 cameras don't work, you're left with a lot of questions. But the way I like to think of it is an atomic hypothesis, where you're just testing the smallest possible unit that you can get feedback on quickly, and then moving up and testing more and more until you have something more fleshed out. And so I only scaled the model after using the tiny data set. Okay, next topic is on the mental side of things. And the way I like to frame this in my head is that the mental side is part of the syllabus. So we're used to a traditional taught degree. If we do computer science, it might look something like this, where each year we have a syllabus laid out for us, and that gives us a nice structure to work through, and increasing levels of difficulty each year that build on top of each other. We know where we sit, and this is a comforting environment to be in. But unfortunately, we don't have any syllabus in the same way for doing research, doing a PhD. But I think if we did have a syllabus, it might look something like this, where in the first year, your task is to overcome imposter syndrome. Then in the second year, you're going to have a lot of feelings like you want to quit, and there are thoughts that there are better things you could be doing and that this is all a waste of time. In the third year, you finally start making some progress, but then you realize that it was all for nothing and somebody else has done this 30 years ago, and you have to throw away 3 months worth of work and somehow try to maintain your sanity after you do that. And then in your fourth year, then you're finally coming to terms with that you didn't do as much as you wanted to do, and you have to settle for the research that you've done. And the reason I want to talk about these things is that, and why I consider them part of the syllabus, is that they can feel a little bit isolating when you first experience these feelings, like they are somehow unique to you, or signs that you are making mistakes or that you're not doing the right thing. But in fact, these signs are universal, and that's why I say they're part of the syllabus. They are courses to overcome, essentially, and every single person experiences these. And if you didn't experience these things, then you would be the outlier. You would be the exception. It's something that is experienced by everyone. And I think a lot of the value in doing a PhD comes from overcoming these challenges, which are inevitable, and that's the word I want to use there. These are inevitable, rather than the book knowledge you gain. Now, I find this a useful way of thinking about it. So when I have these feelings, then I think, okay, well, this is part of the syllabus. This is this is my machine learning course. I know that I'm expecting this to come, and when it comes, I'm not surprised, and I just try to get through it. But of course, if any of these feelings are really overwhelming for you, then of course this mental model is not a substitute for getting help. I just wanted to let you know that you're very much not alone, and these experiences are common. Okay, next topic is on collaborations, which I've decided to call "Take All the Help You Can Get." Okay, when I first started my PhD, my meetings looked something like this. So I'd go to my supervisor Victor with some research ideas, and we'd have a conversation about these ideas, but they were kind of floating in the air, and that's why I've depicted it here in a cloud, because we're having a conversation with each other, and the research is what we're talking about, but it's quite difficult to articulate complex ideas by speaking only, especially if it's not something that you have prepared in advance. For example, that's why we have slides when giving a longer talk. So I don't think this is a very good way to approach your meetings, and I much prefer doing it this way, where instead of having your ideas as this thing that's in your head and is something that you talk about, is to, whatever they are, to write them down. And then this allows you and your supervisor to look at something together and talk about the thing. So rather than talking to each other with the ideas floating in the air above you, you're talking about the ideas which are there on the page, and you can both see them, and you then have something to direct your attention. And this gives you a shared reference point to start talking about things. It can also give you a starting point to start making notes, and then hopefully doing some like whiteboard style discussions where you're coming up with ideas together in real time from the starting point. Now, a criticism or a difficulty you may have when faced with this model is, okay, this is all well and good, Ollie, but I don't have any research ideas. So how am I supposed to write something down? I have nothing to write down because I can't think of any good ideas, and that's why I go to my supervisors to try and get some ideas. Okay, I know this feeling very well. Again, this is a universal feeling. I have two pieces of advice in this case where you're struggling and not thinking of any ideas. So the first one is to lower the bar for what you consider to be an idea. Now, as I've already said, most of your ideas are going to be rubbish, so you need to generate a lot of different ideas. And once you've accepted that most of them are not going to be very good and not going to work out, it makes it easier to lower the bar for your ideas. And almost no ideas are good in their first iteration. Ideas start as some rough plan which doesn't really work, and then you write it down, and it's such a silly idea. It's so small that you feel even embarrassed to write it down, but you write it down, and then you can talk about it. You have something in the flesh, and then you can say, oh well, it's bad because of X, Y, and then we say, oh, X, Y. Well, what about maybe, yeah, it is bad because of Y, but perhaps we can do Z to solve Y, and then you start going down that path where you can massage this little nugget of an idea into something that is actually something you can plan and build into a project. So that's my first piece of advice, is to come up with anything. Anything is better than nothing. And my second piece of advice is to spend more time on the activities that generate the most ideas. So in my experience, running experiments is the lowest ideas generated per hour activity that I do. So if you're spending all of your time running experiment after experiment after experiment and not getting many ideas, then perhaps this is one of the reasons why. So of the four activities that I've listed here, which is giving talks, writing, reading, and experiments, I'd consider the other three, at least in my, again, anecdotal experience, is that the ranking goes something like this, where giving talks is the number one, because when you explain something to somebody else, they will see things that you have missed. Secondly is writing, because as you are forced to, again, explain your ideas, it forces you to justify every step of the way, and then you can also find limitations and think, oh yeah, that is a limitation, why don't we solve that problem? Third, and this is probably what you spend, where you generate most of your ideas from in the beginning, because it does take some time to get the ball rolling for the giving talks and the writing idea generation avenues, is through reading, and especially the discussion section of papers. Authors will often tell you directly what the limitations of their work is, and what some interesting future works might be. So you can use reading to help you generate more ideas as well. But as I say, in my experience, giving talks and writing are the top two. And it can be a little bit frustrating if you have been doing the science loop, where you're doing experiment, hypothesis, and you're looping around over and over again, and it takes you a long time, and you finally get something good, and then you start writing the paper, and then you get 10 more ideas when you write the paper and you explain what you're doing to everyone, and you think, well, I wish I had these ideas when I was stuck in that experiment loop for ages, which is why I advocate for speaking and writing as soon as possible, and that will hopefully help you to generate more ideas. And when I say giving talks here, I'm referring to the seminars, but I'm also talking about whenever you explain your research to somebody, basically. So this can be a supervisor meeting, or it can just be a conversation with your lab mates, where you or other people in the department, or anybody really. Anytime that you're explaining and your research and justifying why it's important, what the problems are, why you're solving things in the way you are. And it can in particular be useful occasionally to get feedback and explain things to people from completely other departments in different fields, because what seems important to them may be, again, very different to what seems important for you. And that can be a useful signal sometimes for generating more creative ideas. So in practice, here's an example of a report from my PhD. So I had this idea for a new problem. I listed what the contributions might be for a paper, what the problem definition was, what data sets we could use, what metrics we could use. An example model is shown there that I've drawn, that I've mocked up. Now, again, this may seem, oh, well, that's all well and good if you have ideas, and I wish I had some ideas. But this model here that I've shown didn't work. I had to throw it away. And there are many other such diagrams and pieces of text in the graveyard, and that's part of the experience. So it's best if you can to generate as much as possible, and acknowledge that a lot of it's not going to work. And once you have a starting point, then you have somewhere to go, and you give your supervisor something to guide. But without that, it can be very difficult to make progress. And this is another example. Some slides I created for a load of ideas. Some generated, some of mine, some that have come from others. And so I created these slides, each one explaining the idea, and then I went through them with my supervisors, Victor and Tanaya, and we looked at each idea and then came to some conclusion as to which was the best, which was the worst, kind of ranked them in this order. And also when presented in this way, you can possibly see interactions between the ideas. And what is to you the most exciting idea is not always what's going to work out, unfortunately. So it's best to generate many ideas rather than get too married to one. So for example, this curriculum learning idea I have down there, number 10, was my favorite. I thought this was really good. I thought it was going to work brilliantly, but I just couldn't get it to work at all, which was a shame. But fortunately, because I'd focused on generating maximum number of ideas, I wasn't too married to it. I could throw it away without losing my sanity and just pick something else and get results with one of the other ideas. Okay, next section is on project management, and I've titled this "Manage Yourself Like You Manage Someone Else." I've observed that people often manage themselves very differently to how they would manage someone if they were responsible for them. So if they were an employee, for example. And this is quite a strange phenomenon, and I think it's almost universal to everyone. I see this all the time, and including myself, of course, we set unrealistic expectations for ourselves that we wouldn't dream of setting for anybody else. And I don't know why that is. We're often harsh on ourselves. So, firstly, set expectations for yourself that you might do if you were managing somebody else if they were in a similar position to you. So they had similar experience, similar skill set, similar personality, etc. Try and think, if I knew this person, how would I try to manage their work? And I'm going to try and do that. So kind of like trying to take a step outside of your body and mind and try to think about yourself as if you were someone different. So I recommend not just sitting down and starting work without clear goals. Again, as you wouldn't do for an employee, you wouldn't just tell them to go and start work and not tell them clear goals. You want to create some structure by separating out the direction that you're going to take and the execution, just as you would do for an employee. So I find it helpful to separate into two different modes: planning mode, which is where you're creating a list of things you need to do and then prioritizing them. And then execution mode, where you take the task and you complete the task and focus on that until it's finished. And then once it's finished, you go back to planning mode, update your plan based on any new information that you gain from completing that task, and then go back to execution mode. And we have this cycle of going planning, execution, and not confounding these two modes. So When we're in execution mode, we're taking whatever we need to do, and even if we later decide that this is not a good thing to do, well, that's the problem with the planning mode, because we're in execution mode. We don't care about the plan. All we care about is focusing and finishing the thing that we were told to do by our past selves. And then we go back into planning mode, and that's where we start to use a different side of our brain, where we're looking at the big picture and thinking about what are the most important things, and not at all thinking about execution. And in execution, this is a more narrow, focused attention type of thinking. And the two are very different skills. So I find it helpful to completely pull them apart as much as possible, and not do a bit of execution and then plan a bit, and execution and plan a bit, and yeah, get them mixed up together. And another key tip I have is to be harsh with what you consider work, but be kind with the number of hours you expect yourself to work. So I see this a lot. I fell to this trap a lot, and still do sometimes. Is that we set unrealistic expectations with how many hours that we're going to work, and when we do that, what happens is we just don't do the work effectively. So we can maybe sit at our desk for that length of time, but if we really ask ourselves critically at the end of the day, how many of those hours were spent actually doing the most important things, it will be a small number. So I recommend being very harsh with what is work, and being kind with the number of hours you expect to work. Because if you're really working and doing the hardest things, the most important things every day, then you'll find that that's quite exhausting, and you need time to recover from it. So I'm a strong advocate for being being harsh when it comes to whether you're working or not, but kind with how many hours you expect yourself to work. And the final piece of advice on this is to learn your energy patterns and structure your day around these. This is something I've found anecdotally very useful, so I'm going to show you how I do this. Again, I try to look at myself as if I was an outsider observing. So when planning brain looks at execution brain, this is what he sees. So my energy generally starts pretty high. There's a small ramp up period in the morning, and then it's sustained high for most of the morning and early afternoon, where it begins to dip. Then I have lunch break, and that's when after lunch, then my energy is at the lowest point of the whole day, and then towards the end, it starts to pick up again. So with this in mind, it makes sense to structure your day around these energy patterns. So when I'm in the early hours, the best thing to do is to write new code or to write first drafts. These are the things that take the highest energy. Then in the afternoon, it's best to do some of these tasks that I know I must do, that are important, but don't take a lot of mental energy. So this is things like if you've got some manual data labeling to do, or spelling and grammar checks. Crucially, it's not busy work. These are both things that I definitely need to do, but they're not going to take a lot of brain power from me. So it makes more sense to schedule these in the afternoon. And although I could label data first thing in the morning, I could do spelling and grammar checks first thing in the morning. That is true. I can't do the other way around. If I try and write new code for the first time in the afternoon, it's not going to be as effective as it would be if I were to do it first thing in the morning. So it makes more sense to do the higher energy stuff in the start of the day, and lower energy stuff at the end of the day. And then finally, when things begin to pick up again, I'll perhaps do some middling energy tasks like editing or setting up some experiments to run overnight. Again, this is just a totally anecdotal, like what my energy patterns are. I know people have very different working habits, and your energy patterns may look completely different to mine, or even you may think that it's random and you can't see any pattern. But this is what I found, and so I find structuring what I'm working on to be effective, bearing this in mind. And so here's a little screen cap from my thesis task manager. So each of these columns is a different chapter. and there's a small task for in each of the cards, and each card has a tag. So orange is high energy, yellow is medium, and green is low. And the tool I'm using here is Trello, which I quite like, but it's quite simple for task management. There are far more sophisticated apps that can do a lot, but I like Trello's simplicity. So in practice, I would in the morning take some high energy tasks, and then after lunch take some low energy tasks, and then perhaps at the end of the day take some medium, or if I'm feeling good, crack out another high energy task. And notice that I think it's quite common to prioritize things when you're doing tasks, but for something like a thesis, there isn't really the same notion of priority because it's all got to be completed at the same time. So I prefer instead to manage my tasks by energy rather than priority. Okay, next topic is on playing the game, following the rules. So this was originally just called playing the game, but I don't want this to be interpreted in an uncharitable way. Uh, when I say play the game, I'm going to explain what I mean by that. Has nothing to do with lying or being deceitful or being manipulative or somehow cheating in any way. Okay, when I'm saying play the game, I'm talking about really just being intelligent with how you structure your work and how you think about doing research. So this is a really interesting paper called Deep Paper Gestalt, which there's a reference down there. I'm going to share the slides so all the references will be made available. Um, these authors did a very interesting experiment where they take some papers that were accepted, and they have another set of papers that they are workshop papers actually, but they consider them as like the rejected papers. And then, as computer vision researchers, they train a CNN to see if it can distinguish between the good papers and the bad papers. And a CNN is not going to learn to read the text or comprehend the content. So how is a CNN going to learn to distinguish between good papers and bad papers? Well, it's perhaps a unsettling realization that it can actually do this pretty well. And here are the activation maps for good papers and bad papers. So in the good papers, we see firstly a large activation on what I call the pull figure, which is something on page 1, which entices the reader. Strong activations on results tables and filling the page limit exactly. And on the rejected papers, we see no pull figure and not filling the page limit as indications that this paper is more likely to be a reject. So, as I say, this is perhaps an unsettling finding because having a pull figure or filling the page limit is not an indication of the content of the paper and whether it's good quality and rigorous science. But nonetheless, papers can still be distinguished between this using these things. So, of course, correlation doesn't imply causation. I'm not suggesting that, and the paper doesn't suggest that if you do these things, you're more likely to have your papers accepted. But I just thought it was worth noting and something to bear in mind when you're submitting papers. So this is what I would consider the standard gestalt for a 8-page vision paper, and based on the findings in their work. Now, I'm not suggesting that you should always stick to these rules, and they're not rules, and it would be very boring if every single paper did look exactly the same as like this. But what I am saying is this is kind of what's expected. So if you want to deviate from these rules, then do, and that's great. And I think more variety, the better. But do so intentionally and know that you're deviating from the standard and that you should have a good reason to do that. Another quick tip I have is that if you have more than one supervisor or collaborator, think about whether you want to meet separately or together. So meeting together gives you, well, it saves you time because you only need to explain your ideas once, and you're more likely to come to some agreement on what you're going to work on next because the discussion is shared. However, there are some distinct advantages to meeting separately, and I think you should do so. Think about whether this is a good idea in your particular circumstance. So the key benefit to meeting separately is you get independent feedback, and this can be very valuable because you can get different feedback from different supervisors or collaborators. And if you get the same feedback twice, then that is a very good sign and strong signal that that is something that you should focus on. Because when you meet together, you don't really get, if you're meeting with, say, two supervisors, you don't really get two opinions. You get like 1.5 opinions because you get one opinion and then you get a second, like slightly biased opinion because someone's already given their opinion first. But if you meet separately, then you get a true two opinions, and that can be very useful. So I think you should use this to your advantage. Think about whether you want to meet separately or meet together. And finally, this is a repeat of the figure that I had from earlier about presenting the presentation I gave on vision-based forecasting. So my motivation for giving this talk was, well, this would be a good section for my thesis. So I decided to give a talk on it, and then that helped me like complete the section and gave me some figures. So you don't necessarily need to work on different things in your seminars and your thesis. Where possible, you can stack work together and make your life easier. And this may seem a little bit cheeky, the first on first observation, but really, if you think about it, if this is something that you care about, it's actually going to be better for your audience as well, because you're going to spend more time preparing your talk because this is something that is really important to you in your thesis. Next section is working at the right level of abstraction. Okay, I'm going to rattle through these last couple quite quickly because I know we only have a few minutes left. So something I learned quite early on is that this research exists at different abstraction levels, and I think this is a useful way to think about research because each level requires a different skill set, and I think it's good to try both ends of the spectrum and see what works for you. So I learned quite early on that I prefer more abstract research. So in the more abstract end of things, we have new problems, new data sets, big picture stuff. And in the more concrete side, we have established problems, established benchmarks, and a real care for these fine details. So, for example, when I started, I began working on video classification on an established benchmark dataset, and this is a very concrete research. To publish at top venues, it's really important to do better than state of the art and use the established benchmarks and established datasets. And this can be quite tricky, as I'm sure many of us have learned. But what I prefer to do, and when I learned that this was an option, it really opened doors for me, is that you don't actually have to use these established benchmarks and dataset if you don't want to. Now, there's a lot of great papers that do, and I'm not suggesting that this benchmarks are not good for research. They absolutely are, but it depends on your brain and how you like to think about problems. So I vastly prefer finding new unaddressed problems and creating data sets to work on them. So this gives you a different challenge. When you're working on a benchmark, your challenge is to convince reviewers that your method is better than the state of the art on the standard metrics, baseline, data sets, etc. But when you find a unaddressed problem, your challenge instead is to convince your reviewers that it's a problem worth solving first, and that you have a reasonable solution. So the challenge is mostly that this is a problem worth solving, because you don't have to convince reviewers of that if you're doing video classification, because they will know it's a problem worth solving. It's a different way of thinking about research. Okay, final topic, 1 minute left. This ties it all together, and that is the idea that, in my opinion, trying is fun. So I've thought a lot about as you can tell, like how to do research and why bother, because like on the lots more fun things to do. Um, well, I think thinking about how to do your research more effectively and efficiently gives you the option of spending less time on your research if you want to, not more. So caring about all this stuff can actually give you more free time if that's something you care about, or it can help you do more research if that's not something you care about. So you have some scope regarding what to choose, um, and the best thing to do is to choose something fun. And my heuristic for this is, would I be excited to give a talk about this topic? And if the answer is yes, then that's a good sign that this is a topic that I'm going to enjoy. And if the answer is no, then I'm probably not going to find it too fun. And my final point is that clarity can make research seem a lot more fun. So compare the statement, tomorrow I'm going to work, right? That statement makes me want to crawl up in bed, put the duvet over my head, and never come out. But compare this statement, tomorrow I'm going to implement this new loss function that I read about last week. And I see that, I think, oh yeah, that's actually something I quite enjoy. I like that's a really good idea, and I want to see if it works. And that makes me actually feel a lot more engaged. And so I find that getting some clarity can make things seem a lot more fun. And fun is essential to maximizing output. It is not something that is opposed to it. So think about how to have more fun and enjoy yourselves. Okay. Finally, a couple more caveats. Don't take any of this advice at face value. Experiment and find what's worked for you. And also, I'm not a robot. I often don't follow my advice. These are ideals to strive towards, not not set rules.